So on page 57, we have a family of graphs. So these are 4 very common functions that we're going to look at. The first one is called a constant function. What kind of line does that remind you of? Is that a horizontal or a vertical line? Horizontal line, okay? Horizontal line, and it says it's below it, but I'm just going to write it above it too, or you can highlight it. But where it says your equation is just going to be y equals a. And a is just, it could be any number. So the equation y equals a is a horizontal line. And that number could be anywhere. The second one is called your identity function. And this equation would just be y equals x. The third graph is what we talked about on Friday. It's an absolute value function. And that would be y equals the absolute value of x. And the fourth function is a parabola, and that's y equals x squared. So these are the main 4, or the only 4 that we're going to talk about. But what we're going to talk about is how we can translate or move these graphs. All right, so remember on Friday I talked about A, H, and K. We're going to talk about that today, A, H, and K. So at the bottom of page 57, we have your translations. A translation is a slide. Okay, so translate means that you shift or slide. Shift or slide. Okay, there are 2 different translations you can do. The first translation is an up and down translation, and that would be your K value. K, notice where K is. K is never inside of the parentheses. Okay, if K is positive, if that's a positive number, it's going to move up. But if K is negative, it's going to move down. Okay, and then we also have H. H is inside of parentheses, or it could be inside the absolute value. So if we're talking about an absolute value function, it's going to be inside the absolute value. If we're talking about a quadratic, it's inside parentheses. So H, that's the tricky one. That is what moves it right or left. So if H is positive, it's going to move it to the right. And if H is negative, that says H is, not his. Let me see if I can, hold on, let me move that H over so it doesn't look like one word, H. H is negative. All right, that's what will happen to your function. Now, H is also tricky because H is kind of deceptive because you have to flip the sign that's inside of the equation. So we'll look at that a little bit closer here in a second. All right, so let's look at these 2 graphs. First of all, example 1 on page 58. What type of function, if you go back to page 57, there were 4 functions on that page. We had a constant, an identity, absolute value, and a quadratic. Chris, this is a quadratic. Does everyone see that? It looks like the letter U. So looking at page 57, if you don't remember, I had you highlight the equation. So this blue graph is the mama or the parent. Okay? So what's the equation for a quadratic, the parent? Y equals what? X squared. Good job. Now, when you compare these 2 functions, it slid, okay, or it translated. What 2 translations happen? And to do that, you would really just compare the vertex, which would be, so this would be the vertex of the parent. This is the vertex of the parent. This is the vertex of the translation. How did it translate? So first of all, Does the yellow or orange graph, I guess it's orange, does it move left or right? Let's start with that. Left. How many hops to the left did it go? From here to here, how many hops to the left? 2. So what does that mean? That means right here, H is -2. Because from here, from this point to this point, it did go 2 to the left. What else did it do? Down 4. And what would that be? That's your K value. So when you're comparing these two graphs, there's 2 changes. Now it says that whenever K is negative, what is that going to make it do? Did it make it go up or down? Down. So it went down 4 units. So whenever that K value is less than 0, it's going to make it go down. So when K is less than 0, it makes it go down. Okay? Now it also says H is subtracted from X. So it made it translate 2 units to the left. So put left right here. Now what I want you to do is let's circle this equation right here. Circle that. Because I want you to notice the equation for that graph. The equation is what trips people up. Because even though H is -2, what do you notice about that in the parentheses? It switched to a positive. H is deceptive, okay? It always looks the opposite in the equation. So H is still -2, but in your equation is X plus 2. K stays negative, but in the equation, H flips. All right, so the translation of the graph of the parent function moved how many units to the left? What number would go here? 2 units to the left. And 4 units what? Down. All right, that's it. So now let's look at example 2. See if you can identify, first of all, what type of function it is, and how it translated. I wish I knew how to text with 2 fingers. I usually have my daughter text for me. Okay, so what kind of function do we see here? Absolute value. So it's an absolute value, yeah. So it's an absolute value function. So the equation for an absolute value is y equals, and then you have x inside the absolute value. That's your equation. Now compare the blue graph to the green graph. When you compare these two, can you tell that it moved? Yep. So comparing the blue to the green, did it move left or right? This one moved to the right. How many to the right did it go? One. So it moved right 1. And what else did it do? Up 2. So because it moved to the right, H would be positive 1. So you're going to put a positive 1 right here. So H is positive 1. H is positive 1 because it shifted to the right one. And K would be what? Positive 2. But let's write our equation. Our equation, you're going to make your absolute value bracket. Now, inside of the absolute value, do I put x plus 1 or x minus 1?
X minus 1.
X minus 1. Because even though H is positive, in the equation, it's the opposite. X minus 1 would go inside, and then a plus 2 would go here. All right, there's one more translation, or not translation, one more transformation. A translation is a slide. And the last thing we're going to talk about is compression or stretching. So let's look at example 3. But before we do that, looking here, the A value, that's the number in front of X. And it can either stretch it vertically or compress it vertically. So if it stretches it, it does that when A is greater than 1. So if you have a number bigger than 1, it's going to cause it to stretch vertically. Another word for stretching vertically would say, you could say it gets narrow, or you can say skinnier. That's what that looks like on the graph. So if you have, for example, off to the side, we'll draw an example. If you have, this is your parent function, we'll say this is the parent for an absolute value. If A is greater than 1, it's going to get skinnier, so it's going to look like this. See how that V gets skinnier, okay? That means it was stretched, okay? If it's compressed, it gets wider. So you can kind of tell from looking at a graph because it's going to look wider. So an absolute value that is compressed might look something like this. So do you see I have 3 different graphs? So the black graph represents the parent. The red graph is an example of what it might look if it gets narrower or it stretches. And the blue graph is if it compresses or gets wider. All right, so let's look at example 3. Oh, one more thing about A. A can also cause it to reflect. So we're only going to focus on reflecting across the x-axis. So when A is negative, we'll talk about y-axis later. If A is negative, it causes it to reflect down. So again, draw a graph. So this is the parent. So if I make A negative, instead of it looking like a V, it's going to look like an upside down V. That's what I'm saying when I say it reflects down. So when A is negative, A actually has 2 different powers. It can cause it to get narrow, wide, or flip. Okay? So let's look at this example, and then we'll start our homework together. For example 3, we have, what is the equation for this blue line? And go back to page 57 if you're not sure. What's the equation? That's the identity function. So what is that equation for that blue graph? Y equals X. So Maya, you with me? Your eyes closed. Yeah. How'd that work? Yeah, how you see with your eyes closed? That's hard. Okay, so y equals x. Right here. Okay. Now, looking at this equation, this is my a value. So that green, negative 2/5, that's going to cause it, a is negative 2/5. So that's going to cause two transformations. The first transformation is going to do, because it's negative, it did flip across the x-axis. And it also compressed. So it compressed vertically and it reflected down. So what are my two transformations? We're going to say it compressed. And it's harder to see that when it's a straight line. And it also reflected in the x-axis. Okay, so take a minute and circle these questions for homework 7. Take out a sheet of paper. We're going to actually get started with it together. So go to don't put away your book, but on pages 63 through 66, go ahead and circle these numbers and take out a sheet of paper because we're going to get started with them now. Keep in mind that the deadline to turn in 1 through 7 is this Friday. So I'll give you a minute to take out a sheet of paper and circle these questions. Y equals x squared plus 4. Is that plus 4 H or K? K. So what is that going to make the graph do? Up 4. That's the only thing you have to say. Up 4. Done. That's the answer to number 1. Easy. So the main thing you need to keep in mind is that H will always be inside of the parentheses or absolute value. K is always on the outside. So the only thing you have to write for number 1 is that it moved up 4. Looking at number 2, y equals, so now we're talking about an absolute value. So this graph looks like the letter V. Raise your hand if you could tell me what you're going to write. What's the answer to number 2? How does that change in comparison to the absolute value of just x? Lex.
Left 3.
Not left.
Oh, wait, up 3.
Not up.
I mean, down 3.
No. Oh, down 3. Down 3 is right.
Down, but I was saying the wrong thing.
Oh, okay. Because, again, this is H. Not H. This is K. K moves it up and down. All right, now look at 5 and 6. Write the transformations for 5 and 6. So for number 5, raise your hand if you know what happens to that one. Right 5, exactly, because this is your H. Now H is what is inside, but you always flip it. So H is not negative 5, H is positive 5. And when H is positive, it moves the graph to the right. So this moves right 5. Go ahead and do number 6 by yourself. What would you say for number 6? Left 6, because that's a negative 6. It goes to the left 6. All right, the last one I want to do with you today is question number 8. So looking at that graph, the first thing you have to figure out is what kind of function is number 8. And then you have to figure out which way did it move. So did it go left, right, up, or down for number 8? So so number 8, we agree that it's an absolute value. So did it go to the left or did it go to the right? Left. How many to the left did it go? 3. So that means H is -3. So your equation would be y equals the absolute value. What would I put inside the absolute value? Would I put an x plus 3 or x minus 3? Not x minus, x plus. H is the tricky one. All right, I'm going to end there. Use this time to work on your homework assignments. Make sure you're up to date because this is the last week to turn in 1 through 7.